See here. So in the previous session, we clearly discussed about what is linked list and what are the types of linked list. So linked list is the collection of nodes. It is the linear data structure. It is the collection of nodes. Okay, where node is the object that contains data and address parts. In the linked list, two types are there: single linked list and double linked list. So single linked list means in the single linked list, node contains two parts: data part and address part. In the single linked list, node contains two parts: one data part and one address part. So it holds data and address of next node. In the single linked list, two types are there. In the single linked list, two types are there. Just a minute, I'm joining your friends. Okay. See, listen. So in the single linked list, two types are there: linear single linked list, circular single linked list. In the circular single linked list, last node holds first node's address. In the linear single linked list, last node's next value is null. Okay, what is double linked list? Double linked list is the collection of nodes. Just a minute. So double linked list, the double linked list node contains three parts: data, address of previous node, and address of next node. In the linear double linked list, this is for last node's next value is null, first node's previous value is null. In the circular double linked list, last node's next value is first node's address, first node's previous value is last node's address. So first node holds last node's address, last node holds first node address. That's why we are calling this as circular. Okay, so this is the theory part we discussed. Okay, now today practical part, I want to create a linear single linked list like this. I want to create this linear single linked list. I'm opening in the Paint. See, I want to create this linear single linked list now. Okay, so here observe, first element is 10. This is one node. I want to create four nodes now. This is one node, value is 10. Here we have to hold address of next node. Second data is 50. Here we have to hold address of next node. Third data is 40. Here we have to hold address of next node. Okay, fourth data is 60. This is the last node. After this, no node is there, so hold null value. So here, this first node's address is in the first variable. This last node's address is in the last variable. Okay, in between some nodes are there, so no names are there for those nodes. Okay, if you want to access this second element, this second data, if you see here, let me explain clearly. So here in the first, this one is the x, this one is the next, this one is the next. So node contains two parts, one data part and one address part. To hold the data, I'm taking x. To hold the address of next node, I'm taking next. So if you want to access this 10 value, we write like this. We write first x. We write first x. We write like this. Okay. So first x means this 10 value will be accessed. If you want to access the second value, we write like this. We write first next x. First next x. First next x means that access 50. So this is first. First next means what? This one. So this first next x value is what? 50. So now here this one is the x, this one is the next. This one is the x, this one is the next. This one is the x, this one is the next. So if you want to access this 40, we have to write first next x. Okay, like that we have to access. Okay, so later again I will explain, just for your understanding purpose I explain now. Okay, now I want to create this linear single linked list. I want to create this linear single linked list now. Linear single linked list. So to create this linear single linked list, first we have to create the node object. So to create the node object, observe carefully here. Now I want to create the node. Listen carefully. I want to create a node. So if you want to create, I want to create a node. I want to create a node. like this. See here. Observe. So this is a node I want to create. So this node I want to create now. Okay, so here this is X. This one is what? Next. This one is next. So this one is X. This one is next. So here I want to hold data. Here I want to hold address of next node. Okay. So listen carefully here. So if, for example, if you want to create student object, if you want to create the student object like this, okay, I want to hold student rule number. I want to hold student rule number and student name. I want to hold student rule number and student name. So to create this object, so to create object like this, so this one is the rule number and this one is the name. So this is S1 object. So like this S1, S2, S3, S4, I want to create student objects. So to create such type of student objects, we defined a class. In the class, we defined properties like this. Class name, I'm giving as student. Okay, what are the properties we want? Rule number. So rule number 10, 20, 30, 40, integer values. So int rule number. Okay, next name. Name is the string value. So write string name. So we defined class like this. Similarly, now we want to hold X value and the next value. This is node object now. Now this is what? This is one node object. Now this is one node object. This is one node object. I want to create node object now. So in the node object, we want X and next. So define a class here. The class name is node. Okay, just like to create rule number name, to create S1 object. In the S1 object, I want rule number name. So like that, I want to create node objects. In the node, I want to hold data and address of next node. So to hold the data, declare X here. To hold address of next node, take node type pointer variable, node pointer next. So here I'm taking pointer variable. Why we are taking pointer variable? Because pointer variable holds address. I want to hold address of next node. I want to hold address of next node. So whenever I am representing node object, just directly I draw this one only. So understand that this is one node object. So in the node object, this is X, this one is next. This is X, this one is next. Just like in the S1 object, this one is the rule number, this one is the name. Like that in the node object, this one is X, this one is next. So X is the data. Okay, next is the address. So to hold the address, I'm taking pointer variable here. So in the variables, you already know that data variable is there, pointer variable is there. Data variable holds data, whereas pointer variable holds address. Pointer variable holds address. Pointer variable holds address. Okay, address of same type variable. So I want to hold address of same type. So address of node type. Okay, I want to hold address of next node. Okay, for example, see here. So in the pointers, you already learned that pointer means pointer is the variable. Pointer is a variable that holds address of variable, that holds address of variable of same data type, that holds address of variable of same data type. Okay, so what is pointer? Pointer is a variable that holds address of the variable of same type. It cannot hold a different type variables address. It can hold only same type variables address. For example, here integer X is there, one pointer variable P is there. Now P can hold address of X. Okay, is this valid or not? Yes, this is valid because X is which type? Int type. So integer address can be held by integer pointer variable. But I'm writing like this: float variable I'm declaring. Float Y I'm declaring. Now I'm writing like this: in the pointer variable, I'm trying to hold address of Y. So Y is which type? Float type. So float type address cannot be held by integer pointer variable. So integer pointer variable can hold only integer address. Integer pointer variable cannot hold float address. So this second statement is invalid. Second statement is invalid. So with this we can understand that pointer variable can hold address of the variable of same data type. Similarly, I want to hold address of the node type now. I want to hold address of the next node. So address of the node type. So to hold address of the node type, I'm taking pointer variable of which type? Node type. I want to hold address of node. So to hold address of node type, we have to take node type pointer variable here. Just like to hold integer address, we are taking integer pointer variable. Like that, to hold node address, I'm taking node type pointer variable. So this class we have to define in the public section. I'm defining these two properties. So this is the class node. Okay. Then define another class with the name linked list. Define another class with the name linked list. With the name linked list. In this, define one constructor. Define one constructor. Define one constructor. Then to add the elements, define add method. To display the elements, define show method. That's it. Okay. So now we have to define one constructor, one add method, and one show method. To add the elements, define add method. To display the elements, define show method. Okay. So define one linked list constructor, then add method and show method. That's it. This is our task. So now we have to define how many classes? Class node and class linked list. Then from the main, in the main, create the linked list and add the elements and display the elements. That's it. That is our program. So now I'm defining the class now. I'm defining the class node. In the, I'm opening developer C++ here. Observe. See here. I'm opening developer C++. I'm opening new file, new source file. Here define a class with the name node. Okay. In the public section, so node contains in the single, we want to create linear single linked list. In the linear single linked list, node contains two parts. One is data and address of next node. So to hold the data, I want to hold integer data. So int x. I want to hold the address. So to hold the address, take node type pointer variable, node pointer next. So node, we are defining node class here. Then define the class linked list. Define the class linked list. Okay. So now observe carefully here. In this diagram, okay, this first node's address is in the first pointer variable. This last node's address is in the last pointer variable. So now I want to create two pointer variables. One is first and another one is last. So this node's address I'm holding in the first. This last node's address I'm holding in the last. I want to hold address now. So take pointer variable. When we want to hold the address, take pointer variable. Okay. So I'm declaring node pointer first and pointer last. Okay. Now define the constructor here. Initially there is no first, there is no last. Initially, when we create the object, this constructor will be called. So initially there is no first, there is no last. So to indicate that first equals to null and last equals to null. There is no first, there is no last. So first value is null, last value is null. Okay. So here in the main, we create the linked list object. I am creating linked list object now. So linked list class object I am creating. Linked list L1. Okay, so when we create the object, this constructor will be called. So when this constructor is called, first value will become null and last value will become null. So this is first reference variable. This is last reference variable. So first reference variable value will become null. This is first reference variable and this one is the last reference variable. So initially there is no first, there is no last. So in the first we are holding null and in the last we are holding null. There is no first, there is no last. No addresses are there in the first and last. So here first, last reference variables are created. So first value is null, last value is null. I want to add the element now. I want to create a node now. Now I want to create a node. I want to create a node now. Listen carefully. I want to create this node. Observe carefully here. I want to create a node like this. I want to create a node like this. So this is the node. This node I want to create now. So in this node, this one is the X. This one is the next. I want to create this node now. So to create this node, so if you want to add the element, we call add method. We call like this. We call L1 dot add. We pass one value. So what is the first element? Now we want to create linear single linked list. We want to create linear single linked list. What is the first element? 10. Okay. So pass the value. Just a minute. Yes. Pass the value 10 here. Pass the value 10. So we are passing the value 10. So we are calling which method? Add method. So now we have to define add method. We are passing integer value. So to capture integer value, take integer variable here, integer argument. I don't want to return any value. So I'm writing return type as white. This is the method. So define these members in the public section. In the public section, I'm defining constructor and I'm defining add method. So now we want to create this node. I want to give this node name as temp now. This node name is what? Temp. This node's address I'm holding is the temp variable. So to create the object, we can create the object in two ways. I want to create dynamic object now. In the previous class, I explained, in the previous sessions, we discussed that to create student object at runtime, we have written like this: student pointer S1. Then S1 equals to new student we have written. Okay, 10 comma Sai. So like this, I explained in the dynamic memory allocation. I explained this point. Okay, so here we are creating the object. So S1 holds this object's address. Student object's address is in the S1 variable. Similarly, I want to create this temp node now. This node I want to create. So to allocate the memory at runtime, we have to write like this. So declare temp here. I'm declaring temp here. So we want to hold address. So take pointer variable. So to allocate memory for the temp, write temp equals to new node. Now memory will be allocated. So this node is created now. So with this statement, new node means memory will be allocated. So node type object we are creating. So node type has X property and next property. So X property, next property. This object created. This object's address is in the temp now. So now this is the temp. Now this is the temp. Okay. Then in this, I want to hold 10 value. Here I want to hold 10 value. Here I want to hold 10 value. So after this, no node is there. So null I want to hold. So I want to hold a 10 here and null here. So for this, what we have to write? Write like this. So if you want to access the X member, if you want to access the X member, so this temp is the pointer variable. So we write like this: pointer temp X. Pointer temp dot X we write to access the X. Okay, to access the X, we write pointer temp X. Instead of writing this pointer parenthesis, simply you can use the indirect access operator. This one I already explained. In the dynamic memory allocation, I explained pointer temp dot X is equals to temp indirect access operator X. So temp indirect access operator X equals to V. Now what happens here? V value will be stored in the temp X. So now what is the V value we are passing? 10 value. So this 10 value, V value is 10 now. Now V value is 10. The 10 value will be stored in the temp X. So now this X value is 10 now. So now we got 10 value. Okay, now here I want to get null. So temp next value should become null. So what we write here? Temp next equals to null. That's it. So with this temp x equals to v, we got 10. Temp next equals to null, we got null. So now temporary object is created. So now, is it first node or not? We have to check. So if first value is equals to null, okay, first has no address. So if first value is null, means that is the first node. If that is first node, this temp should become first node. Now this temp should become first node. So write first equals to temp. So here temp means this node's address. Temp has this node's address. So this node's address, temp node's address will be stored in the first. Okay, now this one will become the first. Now this one will become the first. So now first reference variable holds this node. Okay, now first value is not null. Now first value is not null. First value is not null. First has some address. Now which node's address? This node's address is in the first. So this node's address is in the first. So now first refers to this node and temp also refers to this node. And now this is the first node and this one is the last node. This one is the first node and this one is the last node. Okay, so assign this address to the last pointer variable. So last equals to first. So now this one is the first, this one is the last. Okay, so control X, control V. So now this node's address is in the temp and this one is the temp and this one is the first. This node's address is in the first and this node's address is in the last. So now this one is the temp, this one is the first, this one is the last. Okay, now temp pointing to this node, first pointing to this node, last also pointing to this node. Only one node is there. That one is the first, that one is the last. Okay, now last has this node's address. Okay, one node is created. One node is created. I want to create another node. So to create another node, I am calling add method again here. So L1.add second value I'm passing. So what is the second value? Second element value is 50. So second element value is 50. So 50 I'm passing here. So now which method will be called? This add method will be called. So when add method will be called, first statement is what? Temp equals to new node. So with this, what happens? One new node will be created. One new node will be created like this. So this new node will be created. Observe carefully. So once again, the same topic will be repeated now. Observe. Okay, so now this one is the X and this one is the next. So now this one is the temp now. So this node's address will be stored in the temp. So now this one is not temp. This one is the temp. So temp X equals to V. So now what is the V value? V value here we are passing as 50. Observe. So we are passing 50 value. So what is the V value now? 50. So that 50 value will be stored in the temp X. So now temp X value will become 50. So this temp X value will become 50 now. After this, temp next equals to null. So what is the temp next value? Null. So temp next value will become null now. Okay. Now, observe carefully. Now check whether first value is null or not. Whether first value is null or not. Now first value is not null. First has some address. Now first has some address. Okay, first has this node's address. First value is not null. So this condition is false. So when this condition is false, now what we have to do is, okay, observe carefully. So this node should become, this temp node should become last node's next node. Okay, so last next value should become temp. So we write like this, last next equals to temp. So with this temp node's address will come into the last next. So now this value is not null. Observe, this value is not null now. This value is not null. Okay, here it holds address of this next node. So link will be established. For example, if this node's address is 3000, if this node's address is 3000, that 3000 value will be stored here. Okay, so last next value is 3000 now. So this temp node's address will be stored here. So last next has temp node's address. Okay, now observe here. Here, how many nodes are there now? 2 nodes are there. So relationship established. Okay. So now this one is the first node. Okay. So now this temp should become the last node. This temp should become the last node. Okay. So to make this temp as the last, we have to write one statement. Last equals to temp now. Last equals to temp. So with this, now this one is not last. This temp will become the last now. Now this one is the last. So now this one is the first This one is the first node. This one is the last node. Two nodes are there. So hence we can create the linked list. Okay, now I'm adding one more element. I'm adding one more node. Observe carefully here. I'm adding one more node. Okay, less time is there. I'm explaining fastly. Okay, observe L1 dot add. L1 dot add. I'm giving next element value as, for example, I'm giving value as 40. So we are calling which method? Add method. We are passing value as 40. So now what is the v value? 40. So here temp equals to new node. So temp equals to new node means what happens here? One new node will be created. Here one new node will be created. Okay. So in this new node, this one is the x. Just a minute. Okay. So this one is the, just a minute. This one is the x and this one is the next. So new node is created with x next variables. Temp x equals to v. So now what is the v value? 40. So with this temp x equals to v statement, this x value will become 40 now. So temp next equals to null. Okay. So now this value will become null. Okay. Now this one is not temp. This one is not temp. This one is the temp now. This one is the temp. So this temp holds this node's address. Okay. Here it checks first value is null or not. First value is not null. First has this first node's address. So that comes to else spot. That comes to else spot. And in the else spot, last next equals to temp is there. So this is last. This is last next. So last next equals to temp means this temp node's address will come into the last next. So this temp node's address will come into the last next. So this relationship will be established. For example, if this node's address is 5000, that 5000 value will come into this last next. So this last next value is not null now. It has this next node's address 5000. So this relationship is established now. Now this one is this temp is becoming last next. Okay. So now this one is not last node. This temp should become last node. So to make this temp as the last node, we are adding this statement. Okay. So now this one will become the last node now. This one will become the last node. Now this is not last node. Now this is not last node. This is last node. So now here this one is the first node. This one is the first node and this one is the last node. So hence we can create the linked list. Very simple. Okay. Now I want to print the elements. Listen carefully here. Okay. So to print all elements, of the linked list, I'm defining one method, show method here. So to print the first element, simply we write cout insertion operator first. Okay, first x value I want to access. First x value is 10. I want to print 10. So write first x. That's it. After that, I want to get 5 spaces. So to get 5 spaces, write /t. Okay, that's it. Okay. So to print what we write here, L1 dot show. This is the code. Okay. Now compile this program. Compile. Okay, that is asking to save. I'm saving it in our folder cpp dsw cs humans. So this is linked list 1.cpp I'm giving. Okay, observe here. So that is giving some errors. Okay, I'm rectifying those errors. Observe. So where this null value is there, that is not finding. So null value defined in the IO stream. So here we must write hash include IO stream here. Hash include IO stream. Okay, hash include IO stream. Then here we must write using namespace std. Why we are writing using namespace std? Because cout defined in the std namespace. So we must write using namespace std. In the basics, I explained clearly. Okay, now I'm pressing F9. Observe, just a minute. Save it. I'm compiling it. Okay, now observe here, no errors are there, no warnings are there. Observe below, no errors are there, no warnings are there. Okay, I'm pressing F10 to run. So what it is printing now? 10 printed, observe. So for only first element we are accessing. Similarly, I want to access second element. So to access second element, listen carefully. Less time is there. Only 5 minutes time is there. Listen carefully here. So see out insertion operator. The second node has no name. Observe. First node has first. Last node has last name. The second node has no name. So to access the second element, what we write is first next. First next means second node. First next means this node. First next x value I'm accessing here. First next x. First next x means this prints second element. Observe. Okay, I'm pressing F11. Observe here. F11 for compiling and running. See, second element printed 50. Second element printed 50. First next x means second element printed. I want to access third element. So to access third element, first next x. So this is first. This one is first next. This one is first. This one is first next. First next has this node's address. So this is first next. So this one is what? First next next. So I want to access first next x value. So right here, first next x. See out insertion operator. First next x. Okay. Now observe 3 elements will be printed. Observe here. See 10, 50, 40. 3 elements are printed. So linked list created by using add method. We are adding the nodes, and by using show method we are printing. Here 3 elements are there. So we are writing to access this third element. We have written first next for 2 times. For example, I want to access 10th element. So to access 10th element, we have to write first next for 9 times, then write x. It increases length of code. So that's why what I'm doing is I'm taking one node type variable here, node pointer I. Okay, in the I am holding first node's address. So I refers to first. Okay, so while I not equals to null, if that value is not null, I want to print the value. Okay, so first time this is the I. First time this one is the I. First time this one is the I. Next time this, if this is I, this one is what? I next, right? Okay, so if this one is I, this one is what? I next. So next time I next should become I. So to make I next as I, I'm writing I equals to I next. So before that, I want to print the value. So to print the value, write C out I insertion operator X. That's it. So to get 5 spaces, write /t. Okay. So here, instead of writing this C out first X, first next X, first next X, okay, instead of writing like that, simply I'm assuming first node as I. Okay. So I first, this first node as I. Okay. IX means first X. First X will be printed. So next time I equals to I next. So if this is I, this I next will become I. So now this is not I. Now this is not I. This I next will become I now. So I not equals to null. So it prints the value. It prints 50. Okay. Now if this is the I, this is I next. So next time this I next will become the I. So IX means 40 will be printed. Okay. After this, I next. I equals to I next. So I next value is what now? Null. So I not equals to null. So null not equals to null, condition false, it terminates the loop. Hence, we can access the elements. Okay. Now I'm stopping the session here. Okay. So this is the program to create linear single linked list, and printing single linked list. Printing linear single linked list elements. So this is the program. Okay. I'm stopping the session.